Our next video, direct variation. I can determine if a function is direct variation and find the constant of variation. Lots to talk about. We actually have two equations that represent direct variation. And direct variation actually means is a proportion. So direct variation is proportional. Okay, the two possible equations are y equals kx, or we can solve it for k, and you can solve for k by dividing both sides by x, which is what we've done here. When we divide the side that's y by x, we get y over x, and when we divide the side kx by x, the x's cancel out and you're left with k. So this equation and this equation are the same equation written two different ways. The k simply is the constant of variation. And actually, you are going to recognize that more because the constant of variation is a slope. Okay? It's not called m because it's a very specific slope, and it is titled the constant of variation. Is it a direct variation? So we need to know, does it meet the requirements for either y equals kx or y divided by x equals k? In order to be a direct variation, it can only look like one of these two. So the first one, does the first one look like either of these two? Yes, actually it does. This first one looks like this, so yes, it is. The second one, does it look like either of these two? Yes, it does. The second one looks like this one, so yes, it is. The bottom one, does it look like the one on the left or the one on the right? It does not. This one is a minus. So this one does not look like either of the two direct variation equations. So that one is a no. Now let's try to use it. The amount of money raised for the charity dinner is directly proportional to the number in attendance. $2,000 was raised and 400 people attended. Write the direct variation equation. Now the amount of money raised is my y. Because the amount of money raised is directly proportional, you can also think of that as depends on the number in attendance. So the number of people who attended is my x. So I know I need my equation to look like y equals kx. So my y, the amount of money I raised, is 2,000. So $2,000 equals, I do not know the k. K is what I'm trying to find. And the number of people who attended, that's my x. Well, the number of people attended is right here. So k times 400. Write the direct variation equation. In order to actually write the equation, I need to solve this equation for k. So I undo multiplication, division, dividing by the 400 to get the K by itself, dividing on both sides by the 400, cancels, K equals 2,000 divided by 400 is 20 divided by 4, 5. So I write my direct variation equation, y equals 5x. We're going to graph that last example. We know that y equals 5x. So when we graph, of course, we need our m and our b, or in this case, m and k are the same. So my slope is 5. And I'm going to make it a fraction by putting it over 1. And my y-intercept, we have already determined that I cannot have an add or subtract number on a direct variation equation. So my y-intercept, my b, is 0. And I'm going to put my x-axis here. That's my x-axis. And my y-axis here. And because this was a real-world question, where we were talking about raising money and the number of people, I don't need negative numbers of people. This is people. And this is money. And I know that I am raising, when I have 400 people, I am raising $2,000. So I can start with the 0 here. But I'm doing a charity dinner, so I'm probably not going to be looking at counting by 1. In fact, I'm going to count by 100 on the people. And I'm only going to go to 1,000 on my graph. Okay? And for my y's, for my money, well, if I had 100 people come in attendance, I know that 5 times 100 is 500. So I'm going to count my y values by, let's say, 500. So there's 500, 1,000, 1,500, 2,000, 2,500, and 3,000. And we're just going to graph what's going to fit. So at 100 people, 5 times 100 would be 500. There's my first point. We know that at 200 people, 5 times 200 is 1,000. There's my next point. And 300 times 500 is 300 times 5 is 1,500. 400 we know is 2,000 because they told us that in the question. 500 times 5 would be 2,500. 600 times 5 would be 3,000. And I'm out of coordinate plane, so I'm not going to worry about going any further. But I do have to draw a line for my direct variation. Because I could have had 250 people. And if I had had 250 people, I can move right up my graph to know that my amount of money would have been right here if I had had 250 people. So I have graphed my example. Notice the y-intercept is at 0. Jose works for $10 an hour. Write the direct variation equation and determine how much Jose will earn for 20 hours of work before taxes. So, the number of hours is X. His total pay is Y. And I know that Y equals how much money 10x. So that's my equation. How much will Jose earn if he works 20 hours? Well, I'm going to substitute 20 hours in place of x, and I have y equals 10 times 20. So 200 equals 10 times 20. Jose will earn $200 before taxes. This one is not real world. This one is just the math. Y varies directly with x. So I know y must equal kx. If y equals 4, okay, y equals 4. So 4 must equal k, and x equals 3. So k times 3. Write the direct variation equation. I must get k by itself because I have to write this as y equals kx, and I need a number for k. I need a number there. So I solve for k by dividing both sides by 3. That cancels. I leave this as a fraction. 4 over 3 equals k, and I write my equation y equals 4 over 3x. Another real world problem. The team is selling t-shirts to raise money. Each shirt costs $14. Write a direct variation equation to demonstrate the total cost. Total cost is my y for shirts sold. Number of shirts sold is my x. Graph the equation and determine the cost of ordering 100 shirts. So I know that y equals something x. How much does each shirt cost? $14. There's my k. Y equals 14x. To graph it, I'm not going to graph it because I'm wanting to finish my video here. But you can do just like we did the other one with shirts and cost, and substitute numbers in place of x to figure out how much they would cost. If I had 100 shirts, I have y equals 14 times 100. Y equals $1,400 for the cost of ordering 100